Alright, this is the last hour of Physics 1C for March 30th. And we're looking at this problem here, number 28. Our goal is to find the current through each branch, I1, I2, I3. And then finally, we're going to find the potential difference between points A and B here. Alright, so let's draw some loops. Well, let's do the junction rule first. So let's look at this junction. What's the junction rule going to say for that point right there? We'll call it the JR.
I2 minus, oh no, B.
So I2 is going in. We'll make that one positive.
Yeah.
I think they're all going in, right?
Yeah, all positive.
Yeah.
All right, there we go. I didn't do that intentionally, but that's certainly educational that you can have a situation where all three go in and then they're all positive. That means one of these must be negative, right? Guaranteed. Either they're all zero, or one of them is negative and the other two are positive, or two of them are negative, one's positive, right? It can't be the case that they're all positive, because there's no way you can take three positive numbers and add them to zero, as far as I know. Unless you're in some type of a weird algebra, or whatever they call it. Okay, so let's do some loops. So it seems to me that the most complicated loop would be the loop around this piece. Would you all agree? Because it's going to have two resistors here, and two voltage sources, right? So since we know from the previous problem that we can't use all three loops, we might as well choose the simplest loops. That is to say, the loops that have the least number of things in them. And that would be to ensure that we include the branch that has I3 in it. Okay? So what I'm going to do is, let's make one loop go this way. We're going this way, and back this way. That's one loop that we're going to do. We'll call that one loop 1. And then the other loop we'll just go all the way around the whole system. You don't have to do this if you don't want to, but you can. You could choose to do the other loops if you want to, and that will be loop number 2. Okay, loop number 1. Let's start at point B. Going from negative to positive, what do I get? Positive or negative 5 volts?
Positive.
Yeah, positive. What about the I2 here? I2 times...
In negative.
Yep, negative 1I1, or sorry, negative 1I2. Let's go ahead and go backwards a little bit. Let's imagine that we started here. What would you get for the 4? Now, let's not do that. That's confusing. Let's not be confusing. Let's keep going. Okay, we started at B. We got positive 5, negative 1. What are we going to get in this branch out here? It's going to be 10I3. Is it positive or negative? We are going
Positive.
against the current, which means we're going upstream or uphill, so it's plus. Going to a higher elevations, the way I always think about it. Oh, not quite 0. We have to add in, finally, this term. So we're also going to have negative 4I2. And we might as well go ahead and rearrange this in the form that we want it to be. So there's no I1 terms, right? So this is going to be 0 I1. I2 looks like negative 5. 10I3 is equal to 5 volts. We could even simplify this equation if we want to. We could divide through by 5, but let's not do that. Okay, so that's equation. So we've got this equation. We've got this equation for loop 1. And now we want to do loop 2. Okay, loop 2. Let's start here for loop 2. We're going this way, I1, so we're going to have negative 3 what's the current up there? I1. Going from negative to positive, that's going to be positive 10. Going the same direction, so negative 2. And all the way back around here, and it'll be the same as the previous one. We're going against the current, so plus 10I3. Adds to 0. Did those all look right? Is it negative 5? right here. Yep. It was positive 5 here, so it should be negative right there. I'll put it in red in case anybody didn't notice that. That's right. Thank you, Henry. Okay. Anyone see any errors in the number 2? All right. Let's rewrite it. So we have negative 3i1. Oh, there's also a negative 2i1, so it should be negative 5i1. You see what I mean? That like we started class, we talked about how you can add these things in series, and they kind of just naturally it adds up, right? Negative 3, negative 2, 4 plus 1 is 5, 3 plus 2 is 5, right? So negative 5i1. Whereas there's no i2 in this equation, so plus 0 i2. We're just setting up to put these into a matrix, and then i3 has positive 10. And then we'll have a negative 10 volts on the right-hand side. So those are our 3 equations. These ones would really be quite easy to solve with substitution. Right? Because just like the one we did before, we've got I3 as a function of I2, I3 as a function of I1, and something that we could solve this exactly the same way we did the last problem. But who wants to do that when we can use technology and have it solve it for us? So the matrix that we're going to want to put into our calculators here, and you can go ahead and start putting it in if you want to. This one's 1, 1, 1, 1, 0. I don't really need to rearrange them because they're all positive. This one's going to be 0, negative 5, 10. Negative 5. I don't know about you all, but I just love using matrices. They are a really powerful mathematical tool, also really powerful in computer science, probably.
So much easier.
Yeah, I don't know. I was really surprised when I was studying physics in grad school because of just how frequently matrices are used. If you take 1D, really more if you go on to take a quantum mechanics course, you'll realize that matrices are a huge part of quantum mechanics and a huge part of our modern understanding of physics. We use them quite a bit. Anyway, so we want to do RREF on this matrix. So if we plug this into a calculator and do this stands for reduced row echelon form, then it should turn into something, and maybe you all can tell me what you get, that looks like this. It should be one separate. So it's going to be like 1, 0, 0, and then an answer, 0, 1, 0, and an answer, and then 0, 0, 1, and an answer. What do you all get? And I'm going to go ahead and put it into the one on the computer too, which is here. Again, I need to go out of full screen. 0.8, negative 0.2, 0.6. When the numbers come out that nicely, it almost has to be right? It'd be very difficult for the numbers to just randomly become so nice like you chose there. So it's probably correct. 1, 1, negative 5, 10, negative 5, negative 5, 0, 0, 10, negative 10. I'm sure yours is right, by the way. I'm just doing it myself to just have it show up. All right, so it looks like to the precision that this calculator does, it's 0.79 in it, which is just 0.8. And you got negative 0.2 and negative 0.6. This means that everything's still on the screen. I1 was equal to 0.8 amps. I2 is negative 0.2 amps. Don't worry that it's negative. That's totally fine. We knew that at least one of these had to be negative. There we go. Nice, simple, round numbers. Because this is a problem from a textbook, so of course the numbers are nice and round like this. Okay. Does anyone have any questions? It's all pretty easy, right? We're going to do one next that's a little bit harder. What was someone going to say?
I'm open.
All right. So now how do we do the last part? Any ideas? It says, part B says, to the potential difference VAB of point A relative to point B. What does that mean? What on earth does that mean? And how would we calculate it, really, is the real question. What they're pretty much saying, just as another way of approaching this, is if I were to take a multimeter and I were to hook it up between these 2 points here, or just a voltmeter, symbol for a voltmeter looks like this, you're going to see problems where they're going to draw things like this into your picture, and they're going to ask you, what's the voltmeter reading? It's the same thing. The potential of point A relative to point B would just be, what does a voltmeter read here? How could we calculate that? Any ideas?
I'm thinking maybe simplify the circuit.
This circuit cannot be simplified because of the other battery that's here.
Yeah, that's true.
So we really can't simplify this branch right here because we don't have a rule for what happens to the battery. How could we do any ideas?
I mean, voltage. I mean, there is Ohm's law.
Ohm's law could tell us the potential difference across one of these, perhaps. And probably across both of them, but then how would we add them? So here, this is my method for doing this. This is actually really simple. So all you need to do, what do we want? Point A relative to point B. So pretty much, okay, wait, I can think about this for a second. VAB, right? When they say VAB, God, I hate this book so much. Have I ever told you guys that?
I don't think I just get the relative.
Yeah, what the hell does all this stuff mean? It's just a bunch of
Are they
mumbo
asking,
jumbo.
like the potential, like the drop from A to B?
Yeah.
Or, like,
Yeah, that's what they're asking. But they love this. I'm sure this is quite good notation, and I'm sure a lot of people use this stuff. I hate it. I don't like it. So when they say VAB, they actually mean VB minus VA. That's what they mean. I'm pretty sure that's what they mean. I don't even know sometimes. I'm pretty sure this is what they mean by VAB. I would need to go back and check in the textbook. But it doesn't matter because at the very worst, we're going to be off by a minus sign, right? If they actually mean VA minus VB, well, then we're off by one minus sign, right?
Yeah, that's true. It would just be up to a sign.
The thing is that when it says point A relative to B, it makes me want to think that we want to know the voltage of A relative to point B being 0. So your effect, when it says this, I think it means define the voltage at point B to be 0 and find the voltage at point A relative to that, right? That's what I read that as. You know? Which is why I think it should actually be VA minus VB. But we're not going to worry about it. Instead, what we're going to do is just say, I don't know what any of this stuff means. I'm just gonna make a loop here, basically, okay? And we're gonna go from B to A. Just kind of a partial loop like this, okay? And we'll just write down our normal thing. So the current flowing through the 4 ohm resistor is I2, right? What would I write down according to my loop rule for this like little piece of a loop right here? What would I write down? Current's going left. Do I have to write 4I2. Is it positive or is it going to be negative?
Positive.
Positive, okay. We go around to here. I'm going to have to write 3I1.
And that's negative.
And that's negative. And I would argue this is going to be equal to VAB. Or it's going to be equal to negative VAB. I don't know. Let's get an answer first and then we'll talk about what it is. I think if we have a number, it's going to be easier to say what it says. So 4I2 is 4 times 0.2, negative. And then minus 3I1. I1 is positive 0.8. It looks like we'll get a negative answer. So we end up getting 4 times 0.2 would be negative 0.8 minus 2.4. I think you get negative 3.2. Is that right?
Yeah.
Now we can ask ourselves which potential is actually higher. So we went from B to A, right? Yeah. Okay, we can actually answer this now. We went from B to A, and we got negative 3.2. That means that point A is 3.2 volts lower than point B. So to put that in numbers, if, for example, I'll use 0 first, then we'll use something. If I said that point B had a potential of 0 volts, what would the potential of point A be?
Negative 3.2.
Negative 3.2. So VA is 3.2 volts below point B. And I think the way we did that is consistent with that. Now, what would VB minus VA be? It would actually be the opposite of this now, then, wouldn't it? You'd actually get... So I don't even know if I wrote this right here. Maybe it is VA minus VB. Just because I don't want to confuse you all too much, and I know you'll have to be doing homework that comes from this textbook. What I'm going to do is I'm going to go back real quick to where they define this, which is in this chapter. Where do they do it? No, I don't need this anymore. They're still talking about energy. Okay, wait a minute. When do they actually start talking about electric potential, though? Where do my bookmarks go?
I think it was chapter 26.
There it is. Boom, right here. No, it's this. It's this chapter.
Oh, okay, never mind.
The work to go from A to B is negative of VB minus VA, which is VA minus VB. It's called the potential with respect to B. We abbreviate this. Yeah, oh, it is VA minus VB. Okay, yeah, okay. All right. That's fine. They want to go A minus B. That's fine. Okay, we can do that. So, yep, I got these backwards. This is not VB minus VA. They write it as VA minus VB. But you can kind of see that we figured it out, even though we didn't understand what the hell they were talking about, because of the fact that it said relative to B. And when they do something like this, what they really mean is, like, define this to be some value and then tell me what this one is, right? So we got the answer right, even though I didn't really fully understand the way the question was worded. As I'm sure happens to all of you quite frequently when you're doing your homework. You see something written in your homework and you have no idea what they're asking, even though you probably know the way to solve for it. So, anyway, don't let that stuff confuse you. Just try to use what you've learned. If they give you a problem like this, or if you look at a problem like this on your homework, and it says to find the potential between 2 points like this, or if they draw a voltmeter and they say, what's the reading on the voltmeter? This is how you do it. You just draw this kind of partial loop from this point up to that point, and then just use your loop rules, basically, and it'll give you the answer. Okay? All right, does anyone have any questions? So this problem and the last problem are pretty similar to each other, right? Because both of them involve 2 batteries and like 3 or 4 resistors, right? This one has 5 resistors, but 2 batteries. They're pretty much the same circuit, though. You know? This circuit and this circuit are pretty much the same circuit with different numbers. The only thing that's really different is this question here about the potential of point A relative to point B. So, we got to do something a little more challenging, because it can actually get a little bit trickier. So we're going to do this one. This is one that has 4... So 3 batteries, 3 resistors, and I think what we'll do is I'm going to try to see if you all can't... I don't know. I think I still need to pick directions for current, even if I'm going to have you solve it, right? I should still pick directions for current so we all agree with the currents. Would you all agree with that? Yeah? Okay. So I'll do that, but then I'm just going to have you all try your best to solve this one and just run into the difficulties that happen. So let's go left to right, just to keep things simple. I like things to be as simple as absolutely possible, so for me what that means is just always make the currents the same direction. Just keep it really simple. So we'll make this direction to be I1. We're going to have an I2 here. We're going to have an I3 right here. We're going to have an I4 right here. Now, this problem is, it's a little bit more complicated because now we have a couple branches that are really weird right here. Even though I don't really like doing this, I think I really hope this doesn't confuse you all. We're gonna kind of add a fake current in here. You don't really have to do this, but I think it makes it a little simpler if we do this. Let's call this one I5. We are not going to solve for this one, okay? This is just going to be a tool that we use to write our equations, okay? Specifically, we're going to use it as a tool to write the junction rule for this point and this point right here. How many junctions are there in this picture?
4.
4, yeah. 1, 2, 3, 4. You will not be able to use all 4 junctions. You will be able to use 2 of them, though. And really, those 2 are really only going to give you one equation. But so let's use these 2 junctions. You do your loop rules however you want to, okay? How many loops can we draw in this picture?
5.
1, 2, 3, 4, 5, 6. There's actually 6 loops that you can draw. Because you can draw a loop that just takes up 2 of these. That would be 1. This would be 1. And then you have 1, 2, 3, and then the outside. So that's a total of 6. Can you use all 6? Absolutely not. You only have 4 unknowns. So yeah. Choose what you want. Choose whatever loops you want. And what I want you all to do with this one is I want you to fully try to solve this one. And I want to kind of prove that it doesn't matter what method you choose, you should all get the same answer. Right? So this will take a while. This is not an easy problem. Hey, maybe it is. I don't know. I'll give you like 5 to 7 minutes. Okay. After 5 minutes, I'll just check in. So at like 4:35 or so, I'll just check to see how you're doing.
Would you like us to use that I5 that you drew?
You don't really have to. Here, let's get that issue out of the way because I don't want people to get too confused by this. What would the junction rules say for this junction right here? We got I1 and I2 coming in, right? Those are positive. And we got I5 going out. The other junction is here, so we have I3 and I4 going in. Oh, no. Sorry, I don't mean to be confusing. I apologize. I should have said I1 and I2 go in, I5 goes out, so it's negative. So I should have wrote I1 plus I2 minus I5 equals 0. For the other node, we're going to have I3 and I4 coming in, so we'll have I3 plus I4. And it looks like I5 is also coming in, so plus I5. And now we can reduce these down to one equation because if we add them together, what we're going to get is... So just don't worry too much about the junction rule part for this one. Just that's all we're going to use for the junction rule. Okay? I think that's consistent, right? Does that seem reasonable?
It's as if they're all going into one junction.
Yeah, pretty much. And in reality, this isn't really... Like, you could put these 2 junctions together and it would be the exact same circuit. If that makes sense. Like, we could literally remove this branch and this branch down here and just connect these pieces, and it would still be the same circuit. So, anyway. All right. Try to solve it. You want to write down your loop. Do you want me to... Do I need to copy-paste this down here? This doesn't hurt. In case you want to see it. Even this is just so hard to read. Okay. Give it a shot. Okay, that was about 7 minutes. How are y'all doing? Has anyone got, like, an actual answer yet? You do not need to put the answer in the chat. Was that enough time to get an answer? If not, we can... It was, okay, for some of you.
The equations for the loops.
Almost. Okay, I'll just give you a couple more minutes. Just try to finish up what you're doing.
I was just messing with it topologically.
Topologically?
Mm-hmm.
What does that mean?
Because of that, to get rid of that I5.
Okay.
I feel like this is a dumb question, but I'm setting up my matrix. It's a 3x4, right? And can we use reduced echelon form on a 3x4 matrix, or is there something to reduce it?
There's 4 unknowns, so it should be like 4x5.
4x5, okay.
Yeah. But yeah, I think for reduced...
You're right. I forgot the base, the I junction.
Okay. Yeah, I think reduced echelon form probably only works on n by n plus 1 matrices or whatever. I don't think you can do reduced echelon form on a square matrix, but I could be wrong. I don't... It's been so long since I took any linear algebra. I don't remember much of the stuff. I mean, I remember a lot of stuff. I just don't remember the rules for reduced echelon form and what they work on. Okay, that's been about 10 minutes, apart from the fact that I was talking a little bit there, but let's see if we can't go through and solve all these things. Alright, so let's make this just a little smaller so we have some... Nope. If I want to do that, I'm going to have to select all this stuff somehow, and I don't think it'll even let me do it. Nope. Alright, we'll just scroll down a little bit. Oh, I know what we can do. We can just zoom out. That works. Alright, so go down just a little bit. Alright. I'm just going to do 3 loops that go from left to right here. I'm just going to do the inner loops, because it seems like something to do. I don't know. Why not? What do we want to use? Purple, maybe? So we're going to go clockwise. We'll go 1 loop. That's not purple. Purple. We're going to do 1 this way. That's going to be loop 1. We're going to do 1 this way. It's going to be loop 2. If you didn't do these loops, it's totally fine. Because really the whole point of this was to see if you could do it your own way and still get the right answer, right? So loop 3, loop 2, loop 1. And yeah, let's get going. So I'll start at this point right here for loop 1 and say we're going from positive to negative. That's going to be negative 40. We're going against the current, upstream, uphill, positive, 80, I2. Same direction as the current, negative, 200 I1, 2000. And of course we can rearrange this if we want to, so that we get negative 200 I1 plus 80 I2 plus 0 I3 plus 0 I4 equals positive 40. Does that one look okay to everyone? Speak up if you see a problem. If I start from this point right here and I do a clockwise loop for 2, we're going from negative to positive here. That's going to be 360 positive. We're going against the current. That's plus 20. Swoop it around here. We're going in the same direction as the current, so that's minus 80. And then negative to positive is positive 40. And this reduces down to 0 I1, negative 80 I2, positive 20 I3, plus 0 I4 is equal to negative 360 volts. All right, and then loop 3. Let's make these over here a different color or something, because I don't know, it just looks weird seeing all that purple in a line like that. Okay. For loop number 3, let's start at this corner. We're going clockwise, so down. Plus to minus is negative 80. Back purple. We're going upstream, so 70 I4 positive.
Professor, for number
What's up?
2,
Did I make a
maybe
mistake?
the 40 volts.
Oh, you're right. So it should have been 360 plus 40, which is 400. So this very last one should have been negative 400. Thank you for catching that. Is that good? Okay, negative 80, positive 70, and then, okay, we're going up this one now, so we're going the same direction as the current, so negative 20. And then plus to minus, so that's negative 360 volts equals 0. And then this gets reduced down to, there's no I1s or I2s. And then negative 20 I3. And then positive 70 I4. Equals. All right, so 80 plus 360 will be 440. And it's going to be positive. Does that look right?
Mm-hmm.
There's some things you can check when you do it kind of like this, because with 1 I went down this piece, but then with 2 I went up it. And so as a result, what's going to happen is you're going to have a positive 80 I2 and then a negative, so this is plus and this is minus. Same term, but just reverse signs. You're also going to have the same thing happen with your voltages, so you have a negative 40 here, it's going to be a positive 40 here, positive 360 here, negative 360 here, positive 20, negative 20, and those are the only ones that they have in common. So basically these two branches that showed up in multiple loops, since I went in opposite directions, they should have pretty much the opposite signs. All right, so we've got our 4 equations, which includes this one here, and we can turn those into a matrix. I don't need to make the matrix that big, do I? That's kind of extreme. We can easily fit our matrix into a smaller group. Okay, so they are going to be. Let's use this one first. This is going to be 1 1 1 1 1 0. 1 1 1 1 0. And we have negative 200. Now, don't worry if you didn't get the same matrix, because if you use different loops, you're not going to get the same matrix, right? Just won't happen. but getting the final answer the same is all that really matters. So then the second one is 0, negative 80. Opposite signs. Positive 20. 0, negative 400. And then the last one is 0, 0, negative 20, positive 70. I don't know why I'm writing plus signs. And then 440. So there we go. It's a 4x5 or 5x4 matrix, however you write that. And, yep. Did anyone get the same matrix? Probably not, unless you used... Okay, I guess the first question. Did anyone use exactly the same loops as I did? Not like it's wrong, I'm just curious.
Yeah, I did.
Did you get the same matrix?
Yep.
That's good to know. All right, so let's see what we get as our answers. So we'll go back out of full screen, just shift this over a little bit. Maybe go like that. All right, so we need to do rows. There's 4 of those. There's 5 columns. Create matrix. I think the answer for this one is like 1, 3, 6, 8. Anyone get something like that?
Got 1, 3, negative 8, 4.
Yeah, I got that.
Negative 80, positive 20, 0, negative 400, 0, 0, negative 20, 70, 440. 1348. My bad. Okay, so we end up getting I1 equals 1, I2 equals 3, I3 equals negative 8, and I4 is equal to 4, and these are, of course, all measured in amps. Amp, 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 amp. And that's the answers. There's one other question for this problem. We'll answer that, too. The other question was, find the potential difference across the 200 ohm resistor. Well, that's pretty easy because the current there is I1, so delta V is just going to be equal to I1, which is 1 amp, times 200 ohms, which is going to be 200 volts. We could also, as a separate thing to calculate, we could find the power dissipated by the 80 ohm resistor. So for power, all you need to do is you need to do I squared R. So if we plug in the numbers for example, the 80 ohm resistor, if we want to find the power dissipated by the 80 ohm resistor, we would take I, which is I2. So that would be 3 amps. We can square that, and then multiply by the resistance, which is 80. And we get 9 times 8, which is 720, and this would be in watts. Okay, that's the kind of thing. This is the kind of questions you're going to see show up. It'll ask, like, find the current. Then it'll be like, find the power going through one of these resistors. Also the kind of stuff that's going to show up on the exam next week. And that's it. That's how you do these problems. They are very formulaic. You really just need to be extremely careful when you're setting things up, because you saw as I was doing this, I made several mistakes. In this problem, I made one mistake that you all clarified, which was the 360 and the 40. I didn't add those together. If I had made that mistake, I wouldn't have gotten the right answers. And I think in the previous problem right here, someone noticed that I made pretty much the same mistake in the sense that I moved the 5 to here and I didn't make it negative. So, you know, it's super easy to make mistakes when you're tabulating all this stuff out. So if you don't get it right the first time, in my opinion, it's usually better to just kind of like take your work that you've already done, put it to the side, and just start again and just redo all the loops. Because it doesn't really take that long to do all the loops. And usually when you're like looking through your equations to find a mistake, it's just super hard to notice that you dropped a minus sign somewhere. It is for me at least, but I'm admittedly not very good at that particular thing. So that's really all I wanted to do today. The last topic, which is RC circuits, you can read about it yourselves, but we'll talk about it next time. And we'll do some problems with it. I don't particularly want to start doing it because it will take quite a bit of time just to get through the theory. So we'd really be pushing it. We pretty much get halfway through and have to stop. So I don't want to do that. So we'll probably stop right here, and I'm just going to spend the last few minutes of class talking about next week's exam. So I can't remember if we did this last week, but you have an exam next week. It is a exam where you need to present work to me. Your class meets from 2 to 5, Tuesdays and Thursdays. If you are in the first half of the alphabet, let me tell you exactly where that breakoff's going to be. So the first 15 students are going to go on Monday or Tuesday. So that will be up through Henry. So it looks like, Cam, you're the first person that's going to go on Thursday.
Oh, okay.
And Henry, you'll be the last person that goes on Tuesday. Okay? So if you're in these first 16 names right here, so Ali Ahmad, Jacqueline Aragon, Saul Marquez, Joshua Jean Ayubov, etc. If your name is in these first 16 names here, first 15 names, then be sure that you check your email around, let's say, 11 a.m. or so on next Tuesday. That's when I'm going to be submitting a problem to you. And all you need to do is just show up and present the problem. You need to show all your steps. You can't show up and just give me a picture of your work. You need to basically find a way to show each of your steps. El Camino email, yeah. Or whatever email is attached to... I think it's usually El Camino email. So if you don't check that very often, be sure that you check it next Tuesday around 3 p.m. Because that's how you're going to get your problem. And I will include with your problem the instructions. And if I don't do that, I'll put the instructions on Canvas, but I'll probably do both. In terms of how I'm grading it and stuff, but hopefully this is pretty self-explanatory. You just need to show up, share your screen, solve a problem, answer some questions, and then you're in, you're out. It should be pretty fast. It should take no more than 10 to 12 minutes. I'm scheduling about 12 minutes per person, so ideally you take about 10, which leaves time for questions and answers and people to kind of come in and come out. You do not need to present these problems in front of the entire class. You don't need to be here until you're done. Sorry, you only need to be here when you present the problem, and once you're done, you can leave. Pretty much what's going to happen is I'm just going to be sitting in this channel, the Physics 1C voice channel, and whoever's first, so like Prince Ali, you're going first. You don't need to be nervous about going first. You don't have to, this isn't like a speech class where you have to present your speech in front of everybody, right? So it's just going to be me and you, and hopefully that's not too intimidating for you. I will be helpful to you. I'm not going to be antagonistic. I'm going to be helpful. Like if you do something wrong, I'm probably going to give you a hint or something like that and say, hey, are you sure about this? And if you can fix your problem in the act of solving the problem, I'm probably not going to dock you too many points for that. You know what I mean? Like if you make them, because I make mistakes too, right? You see it all the time. It's completely and totally normal that when you're explaining something and you're doing math and you're drawing diagrams and stuff like that, that you're going to make mistakes. So if I notice something and I point it out and you don't figure out what the problem is, well, that's an issue. But if I notice something and I point it out and you say, oh no, you're right, this should have been this, that's totally fine, you know? So this isn't going to be nearly as stressful, I would say, as most of the exams you've taken in your life. You know, you're not sitting in a room surrounded by your peers and they're all furiously working and you're reading the problem and you don't have any idea how to solve it, and you watch your neighbor and they're just like, they're done with the test or something like that. None of that's going to happen. It's just going to be you and it's going to be me, and you're going to present it, and it's entirely going to be based on your performance during that moment. You're going to have 3+ hours to work on the problem. You only have one problem, so it really probably should only take you about 30 minutes to an hour maximum to prep. And then once you're done, you just show up and do it, you know? So are there any questions about how that's going to go down? Any fears or concerns? Any issues that I could address right now?
Professor,
Yeah.
should we be expecting like additional questions?
Oh yeah, of course. If you explain everything completely and you also include some kind of additional kind of comments about what's going on, it's conceivable that I don't ask you any questions, but almost always I end up asking 1 or 2 questions during the exam. So yeah, you can expect that I'll ask you something, but again, don't be afraid of that. I'm not going to be rude about it. I'm not going to be, I'm not going to bite your head off because you make a mistake, or even if you can't answer the question, I'm going to kind of help you out. So you're going to be graded on your overall performance. I do have to kind of grade these things somewhat strictly. So it's very unlikely you're going to get 100%. No, Jacqueline, that's a great question. So the question is, will the problems be strictly mastering physics or lab manual problems? I'm going to write my own problems for this test. So they're going to be my problems.
Ooh.
Another thing I told my other classes, and look, this is a part of teaching that I really loathe. I hate saying stuff like this, but if you do try to upload the problem to an external site, like Chegg or whatever, what is the other one called? Slater or something like that? I don't know. Any of the other numbers of problems. If I find it, you're just gonna fail the course. You know? Like if you take the problem that I give you and you upload it to one of these websites and then I later find that that was done, I'm gonna give you a 0. And this is the part about it that's even more awkward. I'm probably gonna give multiple people the same problem. Not a lot, but there's 30 of you. I'm not going to write one problem for all 30 people. That would be a lot of work for me. So there's a chance that 2 or 3 people might end up with the same problem. And if any of you upload it, then I'm going to be in the very awkward position of trying to figure out which person did it. And so my default kind of stance on that is going to be that I'm just going to give everyone a 0. Unless there's some way that I can prove that it was one person and not the others, you know? So again, this is the part of my job I hate. I think it is even worse trying to deal with this kind of stuff during the pandemic. I hate catching cheaters. I definitely have caught a lot of cheaters in the time I've been teaching. It's generally not hard to do. So just don't cheat. This is about as much of a layup exam as you can possibly imagine. Because you've probably never had an exam where you only had one problem, number one. And you've definitely never had an exam where you had 3 hours of preparation with the problem before you actually went into the exam, right? So if you decide to take advantage of that and also then go and get someone else to solve the problem for you, and I find out about it, well, I can't allow you to pass the class. And I don't think any of you would respect me if I think those of you who treat this honestly wouldn't respect me if I allow people to do that. So, you know, you're not here to just get a grade. You're here to learn things, right? Yep, Raikun, that's a great question. So the exam is going to cover everything up to and including what we did today. And Thursday. So up through DC circuits, which if you want to look in the textbook and see what that is, I believe that is up through like chapter 27. So it's 21 through 27. That is what? 7 chapters? 7 chapters. And yeah, you'll have a specific start time, but like usually what happens is that people have other things going on, and so sometimes they can't immediately get into the channel. And if that's the case, I'll probably like watch, I would say, as the exam is going on, I would say pay attention to this channel right here, because I might say something like, hey, someone didn't show up, whoever's next can just pop in. So if you're sitting around waiting, you can just pop in. Otherwise, we're going to go in alphabetical order, because that just seems like the simplest. So I will put a schedule up, so it'll be something like 2 p.m. for Ali, 2:12. I mean, I'll show you exactly what it's going to be. It's going to be like this. It's going to be like 2 p.m., and then it's going to be every 12 minutes thereafter. So that didn't work. We have to add more than 12. We have to add 60 plus 12, I think 72 or something like that. Nope. What do I have to add? I've done this before. What happens if I add 1,000? Nope, not working. Anyway, so this would be 212. This would be 224. 236. Eventually it'll hit the top of the hour. 48. 3 p.m. And then so on and so forth. Every 12 minutes, basically. So Henry, yours is going to be... Weren't you the last one? Yeah. The last one would be 4:48 p.m. So there you go.
Professor, are most of the questions that you're going to be asking related to the problem? Is that correct?
Related to what?
To the problem that you're going to give us? Is that You said you're gonna ask us questions, correct?
Yeah, I mean, it's not going to just come completely out of the blue. I'm not going to ask you what the capital of Azerbaijan is or something.
نمک منظور بچه چیز دیگه بود.
What's up? I don't think that person meant to cue their mic, right?
No idea. That wasn't me.
I think someone's mic just picked up some background noise, or they were talking to someone in the background. So we are not allowed to join the voice while the other student is presenting. I think that would be a little bit, you know. So okay, there's two ways to think about this. Number one, maybe you want to join. Maybe you'd want, invasion of privacy. That's what I'm thinking here, Jacqueline, for sure.
Invasion of privacy. بابا چی میگین شماها؟
Who is saying that?
What is going on?
Yasmin? Okay. Yasmin, I'm just gonna mute you for now. Whoops. Didn't mean to do that. Yeah. Next week. That's right. That's right. That is correct. All right. That's okay, Yasmin. Just be kind of careful with your mic. If you want to, what you really want to do is you just want to set up a push to talk key, and that'll usually fix that problem. Let me stop the stream for now because I've kind of answered most of the major questions. So I'll see you all next time.